Good afternoon, everyone, and welcome to the Mapei Academy. Today we're going to be talking about balcony restoration or balcony installations. So we'll talk about the waterproofing, plus we'll briefly touch on the tiling system. I'm not going to go through the whole tiling system. So the absence of a correctly installed system can have both appearance and structural consequences. So it's a big problem in the industry if balconies aren't done correctly. And in fact, the New South Wales Master Builders Association, they state that over 80% of complaints are water related. So the insurance companies are getting on board as well. So they're starting to crack down with builders and designers and so on. It's a big problem. Now, when I say water related, it doesn't just necessarily mean leaking of balconies and bathrooms, but lots of other things. But water is a major enemy of the building industry. There's no doubt about that. So today we're going to talk about the systems approach. It's very important, as far as we're concerned, to actually have a complete system so that we're covered right from the substrate right up to the finish, whatever finish you're actually going to be doing. So we're going to talk about substrate preparation and falls. We're going to talk about membranes. We're going to talk about details, treatment details, and then finally we'll talk about the finishing system. The systems that we're going to talk about today are covered off by our work method statements. They can be found on our website, or you can contact any of our reps and they can get these work method statements across to you. They're a very handy document. They give you a step-by-step guide and they give you options of products. So we work on a good, better, best scenario. And it talks about everything, as I say, as the complete system, so from the preparation right up to the finished surface. The two that we'll focus on today, because we are being balcony focused, the two work method statements that come into this category are the pedestal system. So when we've got tiles or stone sitting up on a pedestal or a pod, and our traditional system of either direct fix membrane or membrane over screen. So during both installation and in service, balconies are exposed to large temperature ranges and driving rain. So we put that up there just to give you an understanding that when putting together a system for a balcony waterproofing scenario, it's a lot more involved than just when we're talking about a bathroom. So I'm not saying it's any more important, but it is a lot more involved, and it comes under a lot more stress than what a bathroom would. So today we're going to, as I say, we're going to stick to the balcony topics in particular. We're going to cover the codes and standards. We're going to cover waterproof membrane types, concrete repair, screeds and falls, junction and joint treatment, balustrade pipe and drain treatment, upturns and termination points of membrane, and then we'll cover off, as I say, a brief cover off of a tiling system over the top. So everything we're talking about today relates to the building codes or the Australian standards. So everything that we're talking about is in compliance with the Australian standards. So we're going to give you, the best practice. So all these recommendations are in relation to standards and codes. So we're working on the Australian standard of the 4654, parts 1 and 2. So part 1 is for us, the manufacturers. It contains the performance requirements of the membrane. Membranes should be independently tested. Mapei, all our membranes are independently tested. And it's written on our data sheet that we comply with the AS 4654. So our go-to membrane for balconies is our Mapei Smart. So it's got a very long history here in Australia of over 20 years now. It's also got a mother product called Mapei that's got an over 40-year history. So they've got a long history in very critical areas. So not just balconies, but we use them in water tanks and canals and all sorts of scenarios, including swimming pools, Olympic size and so on. So in relation to balconies, it allows the substrate to breathe, so we don't actually slow the process down or the job down. So we can work in the dead of winter, where things are subject to moisture or subject to water. We certainly wouldn't put it over a puddled area or a totally saturated area, but areas that are quite wet. This membrane actually allows the breathing process to go, so it allows the substrate to dry off, so we don't have to wait, which is it's a big selling point, and one of the reasons why Mapelastic Smart is one of the biggest selling membranes in the country. It's also got a very high damage tolerance, so when we are doing works prior to other trades, trades can work on it, and they can kick and scratch away on it, and they're not really going to cause any problems. Of course, we always recommend that before you come and do your tiling works, or you come and lap onto the membrane after having other trades onto it, it's always best practice to have a look over it and just make sure there's not any repairs that actually need doing. Our next membrane is our single component water-based membrane, which a lot of people like them for the ease of use. The Mapelastic is a two-part. There's no doubt in my mind the Mapelastic, as I said, is our go-to. It's our much more superior product, but these are very commonly used, the single component products. This is our fast cure product, our fast drying product, so we can recoat after 1 hour, we can tile after 4 hours, and we can flood test after as little as 12 hours. So they are very convenient for that type of thing. But we do have to remember with the acrylics and with the polyurethanes that everything does have to be bone dry. So our polyurethane, our water-based polyurethane membrane, the Aquaflex WPU, very popular membrane. A lot of people like them because they think that polyurethanes are very flexible, of which they are. But again, everything has to be bone dry. So the timing when it comes to a balcony scenario is critical when you are using the acrylics or the polyurethanes. So the beauty of this particular polyurethane is that it is water-based, so we have excellent bonding with tile adhesives. So you have to remember or keep in mind that some of our polyurethanes that are pure polyurethanes or resin-based polyurethanes, however you want to call them, but in most cases they cannot be bonded to. So you might end up having to do a floating screed over the top, or we use epoxy primers to actually try and bond to it. So this type of product, we can bond to it very easily. It can also be left exposed, so in a rooftop scenario or under the pedestal type system. So part 2 of 4654 is for the designers and the installers. It contains the installation rules and design drawings, so they should be followed. We refer to the standards throughout this presentation, as I said, and we're going to look at a few balcony-specific waterproofing aspects. So we'll start with the substrate. We ensure the substrate material is suitable, so fit for purpose, and installed correctly. So we just highlighted in this particular part of the standards that particle board or particle sheeting should not be used for external waterproofing. In fact, we'll give you no warranty at all if we're called in to go over a particle board substrate. It's important, as I said, that the substrate is fit for purpose. So this is just an excerpt from Skyon. There's lots of other sheetings around. We're not picking this one as any form of favourite, but it's just to highlight the fact that in the installation guide for these type of sheets, they do have their fixing methods. So it's important for whoever's doing the installation of the sheeting that they follow the installation instructions from the manufacturers. So they point out where control joints should be. They talk about the butt jointing and even the configuration or the layout of the sheets. So very important documents, and they should be followed. And if you're not the one that's in control of actually putting the substrate down, don't accept it. If you're coming along to put the membrane down, don't accept something that's not right. Get the builder or the installer to actually get it correct before you put your membrane over it. So the old saying of once you touch it, you own it. So make sure it's installed correctly. Concrete repair. So this is a, a big scale concrete repair, of course. This would need to be formed up, and we could either use a structural grout, or they can even patch it back up with another concrete fill. If they are putting concrete together, then we would always put a primer between the old and the new, just to create a good key or a bonding primer. But in most cases, when it's just repairs, the no formwork's required when we use our Mapei Grout T40, T60, or the Plenty Top Smooth and Repair. They can simply just be put straight over a clean substrate, so they must be cleaned. You know, we come onto a lot of jobs when they're about to do the concrete repair where they've chiselled or hacked out the loose or bony concrete, and then they just think they can go straight on. It's always important to have the substrate clean and ready to accept the next product. Excuse me. To patch holes, so what we want to have is the membrane should always be on a flat surface. We don't want to have rough edges of, you know, some of the aggregate or anything like that that's poking out through the top of the concrete, and we just run the membranes up and over it. It's not acceptable. What it does do is alter the film thickness of the finished film thickness of the membrane. So we need to have the area as flat as possible. Not only that, it's membranes are a lot more costly than patching compounds. So something like the Diesel XP4, an outdoor patching compound, and we can also use it to create or correct localized falls. So falls are a critical part of any waterproofing system. There's just no two ways about it. The water needs to be directed to where we want it to actually go. So falls avoid pooling water. Pooling water can increase the efflorescence, and it can also, over long term, you know, have the effect of, or you know, the cause. It can be the cause of leaks when we have water pooling on there. It's heating and cooling and sitting in the system. We just want to try and direct the water away from where we don't want it at all times. And of course, we want to direct the water away from internals if possible. I understand that some people set drains up against structures. That's fine, but normally we would fall it away from the internals. So the standard calls for falls to be at least 1 in 100 for external areas. So it's a very important thing. The faster the water can get away, the less problems it's going to cause over in a long-term scenario. So most falls are normally created using screeds. The standard cement or the traditional screeds, you know, they're used regularly. I used to use it when I was working. It's all well and good if the person knows what they're actually doing, but you know, you can have a lot of variation when it comes to a traditional mix. So contaminants in your sand while it's sitting there in the pile, rain affected, so it's wetter today than it is tomorrow. You know, further down the pile, what's in the sand and so on. So you can have variations, but if they are done correctly, then they're a good way to create falls. Our go-to is our factory blended or engineered screeds. So they're faster curing. They dry at a much higher strength. So a traditional screed, anywhere between 10 and 15 MPa. We're getting up around the 30 to 50 MPa, depending on the product that we're actually using. They also have a lower minimum thickness. So in accordance to the standards, again, a traditional screed should go no lower than 15 mil. We can go down to 10 mil with these, with the manufactured or the factory blended screeds. We have our normal set, which is our Top Gem Pronto, which is after 12 hours, we're ready to work on it. And our Mapei Gem Pronto, to speed things right up, we can be working on that after 3 to 4 hours. So all those characteristics, the faster cure, the higher strength, and the lower minimum thickness, all offer a peace of mind that you're going to get a screed that's the same ratio every single time it's used, and you should get the same strength every time it's used. Now, the big question that we get asked a lot is to whether we waterproof above or below the screed. It's a constant question that we get. It's amazing in this big country that we live in the north, they like to only membrane under screeds. In the south, we membrane above and below pretty much always, and yeah, in other areas they put the membrane on top of the screed. I'll go through the different scenarios, but the bottom line is when we put the membrane on top of the screed, it has the advantage at least the membrane is at fall. So when the water goes through the porous stone or through the grout joints and hits the membrane, it's actually at fall, and so it's going to direct the water to where we want it to go. Effectively it avoids pooling on top of the membrane. So as I say, guiding the water to where we want it to go. One disadvantage of having the membrane only over the top of the screed is that if there is any damage to it, the stone or tile work, and the piece of tile needs to be removed, there's every chance, in fact it's more than likely, because of the bond of the adhesive, if you are using a good adhesive, more than likely it's going to pull the membrane up with it. So the other thing is when you do see cracks up into the tile work, you know, a lot of the times that crack can be reflected down into the membrane as well. So to just have it on top can also be, you know, it have its disadvantages. There's no doubt about that. But as I said, the big advantage is that the membrane is already at fall. When you have it below the screed, if the substrate is not at fall, or even falling in the incorrect way, then the water goes through the grout joints or through that porous stone that I was talking about, through the adhesive, through the screed, and then just sits on the membrane and it's not actually going anywhere. So if you are going to do one or the other, it's usually safer to do it on top of the screed. So we're at fall. We also reduce efflorescence in the system. So at Mapei, our recommendation always is to go above and below the screed to provide the best protection. There's just no two ways about it. So, and we also talked before about that concrete repair. In the concrete repair section, we talked about creating localized fall or putting fall into the substrate before we actually put our membrane on top of it. So we try and have the water falling, even at the worst case scenario, it does get right down to the membrane on top of the substrate, it still actually gets away. Which leads us on to the junctions, joints and penetrations. They're all very critical parts in waterproofing. There's no doubt in my mind that very rarely do you get a leak in the centre of a balcony. It's always, or not always, but it's 99.9% chance that it's going to be at a junction, a joint, or in particular a penetration. So these areas, there's no doubt that they move. So the elongation at these locations can exceed the membrane. So you can see the membrane can actually tear at these points. So that's why I say a lot of the times when we do have leak or we are investigating leaks, we certainly know to go straight to where there's any joins or junctions or penetrations. Quite often you can look into the underside of a balcony, and if there's a pipe that's been put up through the structure, you can actually a lot of the time see that the water is actually coming down around the outside of the pipe, and it's usually because that penetration wasn't detailed properly. So we'll go into that. So for control joints or for junctions, we recommend that we put some form of mesh, bandage, whatever you want to call it, over the junctions. So in this particular case, we recommend our Mapei Band Easy, which is a felted rubber tape. So it's got very high elongation and high strength, just to take up any movement that's actually going to be put forward into these areas, which is no doubt where it's going to be. Just a little demonstration on how these things are installed. So we would pre-cut all the tape. Then we apply whatever membrane you're using. So be it the acrylic or the Mapei, or be it the polyurethane, and that acts as the adhesive for the felted tape. So we push it into the I'll call it adhesive, but into the membrane. Start in the corner and work out. We always would start at the bottom and work up so that we get the watershed theory. So he puts the bottom joint in first, and you'll see he does his wall joint after that, so it comes down and laps over the bottom joint. So it's a simple operation. Well, I shouldn't say it's a simple fiddly operation to put these things in place, but it's an absolute critical part of the waterproofing scenario. There's no doubt, as I said, these are the critical areas. When you are treating saw cuts, this particular tape does have a marking along the centre. This should be actually put over the saw cut or the movement joints, just so that you know where they are, so we can locate them, and then they would actually be mirrored or transferred up into the tile or stonework that we're putting above. The other options that we have when it comes to these type of tapes is we have a self-adhering butyl tape called Mapei Band SA. Again, nice and simple. We would again pre-cut it. This particular one, you can see it's a sticky product, so it's perforated down the middle. So we fold it in the centre, pull the top back, and peel the backing off and push it into place. And then we would flap it up and pull the bottom up and take the backing off again and push it down into place. Then it's pushed into place using a roller or a paint scraper or flat trowel, anything that's going to be able to give you able to be able to push it down into place. So really sealing the actual outside of the joint itself. Just showing that using it as a flashing up underneath the window. You can cut it yourself to make your own internal, external corners. And again, they're just pushed into place, self-adhering. A nice and simple alternative treatment for junctions. We do have of course, the traditional method of, especially for class 3 membranes. We would put using a bond breaker solution. So we put the polyurethane or the neutral cure silicon at the junction. We put it in as a cove fillet, so roughly the radius of the outside of the 5-cent coin. We use that. Then we put a mesh or a fabric or a tape, whatever you want to call it, into the membrane itself, so into the first layer. So very important aspect. A lot of people think that because they're using a class 3 membrane, they don't need to put a fabric or a mesh into the membrane. It's true in a sense because of the elongation of the actual product, but there is no doubt that the meshes or bandages increase the strength of the membrane. So in other words, I can get our polyurethane, our cement-based, our acrylic, I can put it out onto a sheet of plastic and let it dry overnight, come back the next day, I can grab it within my fingers and actually just pull it apart. It'll stretch and stretch and stretch, but quite easily it can be pulled apart. When we put a fabric into it, the strength is increased dramatically, like it's almost impossible to pull it apart. So as I said, we're in the critical areas. So I believe the membrane should be strengthened in these areas if you aren't using a butyl or a rubber felted tape. Likewise, when we've got sheeting in cement sheet or different types of sheeting lightweight structures, we make sure the gaps are filled with the polyurethane, so the PU45, and then we reinforce the membrane with that Mapei cell. So the Mapei cell is the polypropylene fabric, as we just talked about. People call it bandage, it gets referred to all sorts of different names, but it strengthens the membrane, which enables it to have a far better crack bridging ability. The other alternative to the polypropylene or the paper or the fabric type products is a fiberglass mesh. What we're finding these days with the Skyon type products or Secura or where the sheets are about 600 wide, by the time they've done the detail on every single joint on the balcony, we're actually training people up to just put a mesh over the whole area. So it's a much faster way to apply membranes, and it also governs the thickness of your membrane. So the mesh into the membrane does a couple of different things. It takes the the transition at a floor wall junction. It moves the transition point, so where the membrane goes from thick to thin, it moves it away. So even if you are only using 100 mil tape or mesh, it takes the transition point 50 mil up or 50 mil out, away from the actual critical area right at the wall floor junction. It also strengthens the membrane, as I said, but another thing that it does, it helps you to create or maintain dry film thickness. So when the mesh or the fabrics are completely hidden, so you can almost not see them in the system, it means that you're going to have a nice or as close to the correct film thickness that you actually need. So all these membranes, when we test them, they're tested to a particular film thickness. So a cement-based product should be up at around the 2 millimeters, and according to the standards, 0.8 for the acrylics or the single parts, but I like to say that they should be up at least around the 1.2, even 1.5 millimeters in thickness. So it gives them integrity and enables them to work the way that they were designed to work. If they're too thin, we have a saying of if you can see through the membrane, the water's going to get through the membrane. So it is a very critical thing to get the required film thickness. We hate it when people ring us up and say, "Oh, I love your new membrane because we get 30 meters out of a bucket," when they should be getting 15. So we know that they should be, what meterage they should get out of a bucket, and it's critical to get that film thickness. When dealing with structural joints, obviously they're greater in movement again. They allow the whole structure to move. So we need to step up into a different type of mesh or tape. So we use our Mapei band TPE, which has got a gasket type scenario. So it's got fabric on either side, as you can see in there, but it's got a PVC, or in another Mapei band, it's got a rubber insert that they're highly flexible, and we can use them to loop down into the joints themselves, and then we lock in both sides using the epoxy, the Diesel X PG4. You can see in that picture there, it's looped down probably about 10 millimeters. So, we try and work out, either the site engineer or someone let us know what the expected movement is going to be. We've dealt with car parks where we've been told we've got an expected movement of 35 millimeters. So we loop the membrane down at least 5 to 10 mil greater than what the expected movement is going to be, so that there's no tension ever on that gasket part of the tape. So how to put it in is we basically, obviously the area's got to be clean, like we said before. We put epoxy down onto the substrate, lay the TPE down into the epoxy, loop down in, as I said, as much as we need it to loop down, and then we would overcoat that with epoxy back over the top again. So we sandwich the felt in with the epoxy, and then we sand seed it to create a grip. So when we come to bonding to it, we've got a nice keyable finish to bond to it. So we always would like you to sand seed. So now onto penetrations. We look at 3 different types today. We look at drains, balustrades, and pipework. So the drain treatment to start with. The drain needs to be set up correctly. So we don't want to see this where the puddle flange is sitting on top of the substrate, because what it does, it creates a damming-like effect, or so when that water that we talked about before goes through the porous stone or through the grout joints, through your adhesive and hits the membrane, if the membrane's at fall and then it's got an obstruction just before the drain of that 3 mil lip, you can see the water needs to get to 3 mil before it's actually going to get down the drain. So we're always going to have basically 3 millimeters of water sitting under our system. So we don't want to create an island out of the drain. It actually needs to be the lowest point, or the point where the water is going to end up in most cases. So it needs to be flush with the substrate. So we either flush it, or so it's rebaited, or a minimum flush with the substrate itself. So even if they're a cast-in drain setup, they need to be jackhammered, or they need to be cast in so that they are flush or rebaited with the substrate itself. Always needs to be nice and flat. The important thing also is to get the outer side of the drain nice and firmly fixed. So we quite often walk onto jobs and the puddle flanges are just fixed in place using a polyurethane, and you stand on them and they move up and down, so they flap, so you've got that deflection taking place. You can see that the outside of that flange can actually become a cutting edge if it is going to be going up and down. So the membrane's bonded to it, so the membrane's going to go up and down with that bouncing outer edge until it just gives, until that movement is just too great and the stress takes place and the membrane breaks at that point. That's where you do get water running down the outsides of the pipe. So it needs to be firmly in place and flush or rebaited into the substrate. And then around the outside, we would just do our polyurethane bead just to, create a bond breaker scenario. Then if there is a bigger void to fill, so if it has been jackhammered out and they need to sit the waste or the drain in there and it's not sitting properly, then the area should be smoothed off with our concrete repair mortars that we talked about before, so the Planetop Smooth and Repair. So again, it sits nice and firmly, there's no deflection or flapping taking place. After that, it's all set properly, we would prime the PVC. It's always not a bad idea as well to even give it a light sand, but prime the PVC with our resin-based single-part primer, Eco Prim Grip. It's our biggest selling primer. It's a fantastic product and should be in everyone's van or ute or truck, whatever they're working out of. Then after that, we would make sure that we put our fabric or our mesh over that junction, because it is a junction. So when we think about what we talked about before, wherever something meets something, that's a junction. So it should have the reinforcing put into the membrane. Balustrading. So the challenge is movement. So when we've got wind pounding up against, balustrading, the posts move around, they vibrate quite heavily. There's also the difficulty of bonding to the metal, and there's the sharp edges and corners that we'll deal with today. So if it's a cradle type setup and they are being fixed into the concrete, they should be put in with a chemical anchor. So we have our epoxies or our VEs, our pre-mixed chemical anchor products. They should be the hole should be pre-drilled and then filled up with epoxy or the chemical anchor, and then the fixing should be pushed in place. And it's a good idea to actually see physically that chemical anchor is oozing out the top. Then we know we've got a nice filled hole, and we know we're going to have a nice waterproof scenario. Then we would prime all the steel or the metal. Then we would cove, so where we've got the sharp edges. So again, like I talked about before, when we make everything smooth, even the concrete surface, it's likewise here. We don't want to have a sharp edge. So we would cove it off using our Mapei PU45 again, so polyurethane, and then the membrane would be applied up and over that and as high up onto the stirrup or the bracing or the whatever kind of fixing you've got in there for your balustrading. So pipes are another challenge. They're typically, they should be surrounded by foam, and they are cast through a structure. So they allow for the sideways movement. And what a lot of people forget about is the vibration that takes place in the pipe. So when we've got stacks running through high-rise buildings or even into a second story, the water coming down at a rate going through the pipe does actually create some vibration. So you've got a lot of movement where the pipe is going through or meeting the structure. They also move thermally as well. So they expand and contract with heat and cool. So again, we talked about having the high elongation with the membrane, but in most cases, it's not enough for this type of area. So you can't just paint a membrane, like put a polyurethane bead around the pipe and then paint membrane up onto it and expect it to be a long-lasting scenario. It's just not going to. It'll last for a while, but not for very long. So we refer back to the standards again into the 4654.2. Now that actually calls for a collar. So, and it should be physically or mechanically fixed to the substrate, independent of the actual pipe itself. So, we've seen a lot of people even just use an upside down puddle flange, but some form of collar needs to be fixed into place for the pipe to run through it, and as I say, being independent from the structure. So again, we make sure the chemical anchors are used for the fixings. Then we would fill it again to get rid of the sharp edges, and prime it if necessary, and then the membrane would go up and over onto it as well. And also the standard also calls for a flashing. Now, in my 37 years, you rarely see these things, but they should be used. They are, as I say, they're recommended in the standard, and the standard is a minimum, so they should actually be used. The top of the flange is filled with the polyurethane, and it's a nice flexible joint, so it allows the pipe to still move freely. So the flashing itself that comes down over the collar can actually move independently of that collar. So the last thing that we're going to talk about in relation to waterproofing is the topic of the terminations. So the membrane must be taken high enough to stop driving rain or bouncing rain or wind-driven rain. Very, very common problems in balcony scenarios. So, we've all seen this looking out our window, and we've seen the rain coming in sideways, hitting windows. We've measured it on high-rise buildings, on some cases going up the windows 110 mil, and hitting the tiles or the floor finish on the balcony and bouncing up and getting underneath subsills and so on. So it's a very critical area and must be taken care of. So we refer again back to the standards. It talks about the wind or the areas or the wind classes where you actually live. So whether you're living on the top of a hill or the bottom of a hill, whether you're in a windy area or a non-windy area, the termination point does vary. I believe that you should take the membrane should go up as high as possible in all cases. So, if you can get it up that 180, well and good. But I think at a minimum, it should be up at least 100 mil at any four-wall junction. The minimum is to do the face of the hob or the set down. We certainly believe that you should go above and beyond that. You can see in that diagram there where the subsill comes out and it's got that little kick out. That is a good area or a really good catcher's mitt for rain, as I was talking about. So when it's blown in there or when it's bouncing, even when people hose or clean their balconies with a hose, the water that's directed down onto the tile can bounce back up, and that little flap as such will actually direct the water up behind the subsill itself. So we believe that you should go up and over the top. The membrane should terminate at a water stop angle, if that is applicable to the design, or we would take the membrane up over the top and down the internal face and into the residence itself. So basically what we're trying to do is stop any water that does get into this area. We don't get it going into the concrete or any porous substrate. So, a lot of domestic builders still use pine for their hobs or set downs, and obviously when water gets to timber, it swells and causes all sorts of problems. So we try and basically encapsulate the whole hob or the whole set down with the membrane itself before the subsill goes on. In a lot of domestic areas, the subsills get put into place, and then the person come to do the waterproofing is actually trying to get membrane up and behind these subsills. It just doesn't work. So in the high-rise area, this has been done for probably the last 17, 18 years that we've been doing the whole hob, the whole set down. In the domestic areas, builders are coming around. So some do, some don't. We certainly try to, make it a source of information, or make it show them that it's a very important aspect of waterproofing scenario. So a lot of the times, again, when we come to investigate leaks on balconies, quite often we will plug up the balcony and flood it. You might put 10, 20 mil of water onto it and nothing happens. But when you take it up higher, so it's getting up behind that subsill above where the membrane was terminated because they couldn't get it up any higher, and then it enters into the residence. So as I say, we'll touch on the tiling system. We're not going to go too deep into it because we do have other webinars on tiling scenarios. So, but we do have to remember, and we said it right at the beginning, but balconies are subjected to, extremes of temperature. It might be 15 degrees overnight and then 40 degrees today, or it might be 40 degrees all day and Mr. Jones comes home and decides he washes his balcony and, puts the hose onto it, or it might be 40 degrees today and then rain tonight. So it's subject to a lot of thermal movement, and in the lightweight structures, even in the concrete structures, it's also subject to the structural movement as well. So our starting strength when it comes to an adhesive is a minimum of a C2. So again, we've had webinars on our adhesive types and usage of adhesives, and we talk about the classifications. A C2, the C is cement, the 2 is modified, or it's got polymer into it. So a minimum of a C2 product should be used out onto a balcony. And then because it is exposed to all that sun and the thermal stresses and so on, or we've got a dark coloured tile or stone in particular, you get a charcoal tile like that, for instance, out on a 25-degree day, and you can't stand on it with bare feet. So, you get it onto a 35-degree day and you can literally fry an egg on them. So they are taking on a lot of heat, and that needs to be taken care of. So when it comes to that, it just shows, we're showing you here the stresses. So there's the stress of the tile expanding and contracting. So it's got that shear pressure on the tile. So you can see it moving at a different rate than the substrate. Depending on what your substrate is, it might be X amount of degrees cooler, or it might just handle or move differently to when it's subject to the hot and cold. So when it comes to the next step of adhesives and into the classifications, we look at the S. The S is for the deformability of the adhesive. So absolute minimum we would recommend would now the C2 and a minimum of an S1. When it comes to using dark coloured stone or large format stone or tile, then we would even go higher again and go into the S2. So the highly deformable adhesives. So they've got a much greater ability to actually handle the stresses that's going to be put onto the adhesive. The tile adhesive is designed to handle the movement, the differences between the tile and the substrate, as I said, but we also need expansion joints. Expansion joints or movement joints to take up movement of the tiles over a larger area. So you need to have this movement joint should be totally free of any rigid material, so no adhesive in it at all, and then filled with a flexible sealant like a silicone. We also need the movement joints to not only to expand, but they also need to be able to compress as well. So again, very important to have no rigid material inside that joint and fill it with a flexible sealant. Without expansion joints, the stress builds up until the tile has to move, and obviously they can't go down, so the only way they can go is go up. And remembering we have stepped up into the adhesive system of the C2, S1 or S2, so not only do they handle greater movement, they also have a greater bond. So we're bonded to a membrane. You can see there if the tile goes up, it can take the membrane up with it. And Joe Blow comes home and thinks, oh, why have I got a peaking tile, and stands on it, and it can go, one goes down and one stays up, and that's where you get that scissor type action, and the membrane can be split at that point. So if the tiles pop, as we said before, it will tear the membrane in most cases. So The frequency of the expansion joints or movement joints, it is covered off in the standards, so 4.5 meters, but or 4.5 to 4.8 meters, but it also can be determined by the type of tile or stone, and in particular the colour of the tile or stone. So the darker it is, the more frequent the movement joints actually need to be. So at a very minimum, you would do a full perimeter joint around any posts or pipes or anything else that we've talked about. But the frequency is certainly governed by the colour. So instead of having movement joints at the 4.5 for a white or cream type tile, if you have got a dark coloured tile, I certainly recommend to double the frequency. So, and I know a lot of people freak out on that, and a lot of designers think, oh, expansion joints or movement joints are unsightly. They're there for the longevity of the tiling system. So they're a very, very important aspect. So in addition to offering the normal setting products that we talked about, so we're still into the C2 and into the highly deformable, the S1s or S2s, but we offer the rapid setting system. So again, it's for two reasons. Obviously, to get the job done faster, so we can traffic the area more quickly to grout it up and hand it over to the people. But what it can do is help us avoid weather conditions. So if we know that there's rain coming tomorrow, we might use a rapid set adhesive today because we know it's going to be at full strength before it's exposed to water. The other thing is when we are putting a non-porous tile, so like a porcelain onto a membrane in the winter months, especially in the large format, the adhesives take a long time to dry. So, if you're using a normal set product, you might finish work today at 4 o'clock, come to work tomorrow at 7 o'clock and walk out onto the balcony and unwittingly actually break that bond because the bond or the adhesive actually hasn't got to its full strength or to a strength that enables it to handle you working on top of it, so twisting and turning and so on. So rapid sets are, in my opinion, they're not only important for getting the job done quickly, very, very important for beating weather scenarios, but they're also a real safety aspect of being able to traffic the area with knowing that you're not going to actually break the bond of the adhesive. So in my opinion, whenever you're working over waterproofing membranes, it's a good idea to use rapid set products. You can visit our online, go on to we have those webinars that I mentioned before about the adhesive types, and we've done one on efflorescence and large format, and next week or the week after we're having one on swimming pools. So, but the ones that we have done are all actually on our website in the Academy section, so you can certainly visit that online. So thank you very much for your attention. I will be hanging around for questions. I forgot to mention at the start, which I always do, and I'm sure our organiser is laughing at me because I forgot to say that you can type in questions. I'll go to that section. Why? Yeah. So I can't see any questions there at the moment. My details are on there, or you can contact Mapei anyway if you do have any questions. I will just talk about the work method statements that were mentioned right back in the early stage of this presentation. They're a really good go-to thing to give you an idea of the difference in different parts of the system. I think they're a really good tool for any designers and installers to actually to have a read of and have a look at, and they're also a really good thing for all the installers to use as a selling tool for yourself. So if you're going to give a price to someone, it's a good idea when you do hand over your price, you've given the work method statement at the same time, and you say, well, this is why I'm slightly more expensive than Johnny come lately. It's because I use all the best of these different scenarios. So they're a really good selling tool. It makes you look more professional. We've taught a lot of tilers to use them. We've taught a lot of tilers to use them so that they can actually give a two-tiered price as well. So to give a price to match Johnny, or they can give a price to say this is why I'm a bit more expensive than him because I up, you know, the classifications of all my adhesives, all my membranes, and so on. So I do things correctly or to the book. So anyway, I hope you enjoyed it. And as I say, I can't see any questions, so I'll sign off, and we'll see you on the next one.
Well, there is one question here.
Oh, there is.
What do you do to repair hobs thresholds where membranes have failed?
Okay, that's a good question. Obviously, we would have to remove the tile, and or if there is a screed there, we do have to remove it so that we can get right down to where, you know, to find out where the problem is, especially if it's at the junction of the hob and the substrate itself. Then we need to expose that area so that we can get right down to it. It can be difficult to take tiles up, as I said, and then actually have membrane left to lap onto it. But if there is a screed, it's quite easy. You can just grind it down, or if the tile, porcelain tiles, might just pop off the adhesive without dragging the adhesive up, we can just grind it down and lap back onto it. So, but it is very important to get right down to where the problem is, and then it should be corked and meshed again, or using one of those the felt tapes or the self-adhering tapes that we talked about before.
That's all the questions.
All righty. If my email's up there for whoever asked that question, you can send that through to me, and I can certainly explain it with a bit more detail. Or if you have got photos of an actual scenario, then send it through, and we can certainly come up with a complete system to get it repaired. All righty. Thanks again for your time. Enjoy the rest of your afternoon. Thanks, Katie.